Flexible boards have been developed to meet the need for smaller and higher density mounting designs for electronic products. It can be freely bent, coiled, and folded without being damaged, greatly reducing the size and weight of electronic products. Flexible boards are widely used in the computer, medical, aerospace, automotive electronics, and consumer electronics such as notebooks and cell phones. Let's take a look at how flexible boards are made next. Unlike rigid materials, flexible materials are packaged in rollers. The rolls of material need to be cut to the required size, according to the customer's requirements. The main equipment are two kinds of automatic opening machine and manual cutting machine. The next step is to drill through holes or locating holes in the substrate. You can see the surface is covered with a layer of aluminum, which protects the board from wear and tear. This requires a black hole to form a conductive layer and then plating the hole with copper to achieve conduction. After that, a photographic film needs to be pressed on the plated board surface. After development, the line graphic will appear on the board surface. This step is etching and defilm. Look, the board changed color. Isn't that amazing? Those are the steps for the wet zone. Let's move on to the next one. This step is to apply an overlay film. Also called an insulating layer, it serves the same purpose as solder mask on rigid boards. In order to protect the line graphic, prevent short-circuiting, and oxidization, this film is also available in several colors, are typically yellow, black, and white. Let's take a closer look at the finished product with the overlay film applied. Multi-layer boards require an additional pressurization step. Each layer is firmly pressed together by high temperature. On the screen, you can see the temperature and time are set in advance in the computer. In order to paste the components more accurately later, it is necessary to print the characters in the specified position. Then the FPC should be comprehensively tested for functionality. For molding, flexible boards are usually laser formed. This way of cutting seam quality is better, less likely to cause deformation, and effectively guarantee the size and quality of the product. Because the flexible board is too soft, it needs to be reinforced in some specific places. Reinforcement is generally polyimide, electromagnetic shielding film, FR4, steel sheet, backing, and other accessories. Finally, appearance inspection of FPC according to Customer's Requirements or IPC inspection.